Hello friends and welcome back to my shop. This week is going to be like stupidly hot, like 40 degrees hot, which for Canadians, that's quite warm. So no hair wax in my hair because it'll melt the wax out of my hair. You don't care about hair wax. What you care about is pens and machining and whatnot. So when I plan a new variant for a design, for instance, this one, I typically take what everything is going to take me and triple it because that seems to work better in real life. However, in this case, I actually came ahead of schedule, which is quite pleasing. So this, I'll put proper pictures here. This is the new variant of the Fluux design. Basically, it's the Fluux pen. This one's in brass, polished brass. It's a prototype, so it's got some changes I want to make. But it also has a titanium clip, it has a titanium tip, and it has a new snap action cap. So the cap, oh, so pleasing. And I also put double magnets in the back, so it has a insanely strong post, which is just anything that I had on the old Fluux design that I wasn't 100% happy with. I went ahead and made the changes here. So, but this, oh, that's my favorite. So listen to this thing. Oh, I like that. I very much like that. And the titanium anodizing pattern on this is just absolutely insane. So pleased with this. So let's focus, right? Let's get into the proper video where I can show you more details. The next hardest aspect of building basically anything with moving parts or parts that slide against one another is determining its life cycle. So I'm not going to sit here and take the cap on and off this pen like a million times because that's a lot of work. So I ran it in my CNC machine and basically just cycled the cap on and off this specific pen 4,500 times just to see what it would feel like. And after 4,500 cycles, you can probably hear it. The click is a lot quieter, and you hear that? So this is canting now. And the reasons it's doing that is on this specific design, there's only about a 5,000 interference between when it's expanded over that ridge and when it clicks over it. 5,000 on the brass side, and the brass side is the side that's going to wear. The titanium is just not going to wear. It's just so much harder than the brass. The brass is self-lubricating. There's reasons I picked these metals, but I want that better, way better. Obviously, 4,500 cycles is not what I want for a. I mean, it's fine, but I want it better. So I changed some stuff up. So on this one, this is basically the same kind of geometry. We have brass and titanium. I haven't polished this or anodized it, made it all pretty. Well, I polished it, honestly, because that's very important for the cycling. So this one, I've moved the flexure points. There's same style of cutouts here, but I've made these little leaves thinner, and I've made it thinner into the body of the pen. And then on this cap, I've made this ring more proud with a bigger drop. So I was able to make the finger ends on this thicker. Long story short, it just gives me more brass to wear away. And by moving that flexure point back, I was able to retain the same kind of nice feel that I want. But it should be putting more of that stress into the flexing of the metal and less of it into the wearing of it. So anyways, we're gonna run that through a bunch of cycles and see how that performs. So while the CNC is cycling the cap, I decided to start tearing into the hard-hinge lathe motor. I actually pulled this motor out of the lathe late last night and started doing some checking on it. So like I said, this is a 3-phase 600 volt motor. It's only 600 volts. Normally on the side breakout panel of a lot of these motors, you can switch the winds from delta to star, basically just changing the voltage. Since this lathe runs on 600 volts and everything on it is 600 volts, and it basically down regulates its own power, there was no need for them to put breakouts in this. So when I open the little side hatch panel, the wires, just the main feed wires, just come in and go right into the coils. There's no way to change it that way. But I thought this coil would probably be used in multiple motors. It's not like they built this specifically only for this motor. So I had an inkling that there would be series coils on each phase. So it's a star wound motor from my resistance checking. It seems to be star wound with 2 coils in every phase. What that will let me do is probably, I can either switch it to delta wind, which should be fairly easy, or I can switch it to a parallel star configuration. I've been actually trying to look up that. It doesn't seem to exist, or at least I can't find much information on it. I'll keep digging. but that effectively will let me run half the voltage. I won't get the same amount of power, just because the way everything works, but I think it should work. There's no real reason it shouldn't. I'm not changing the position of the coils, and I'm not changing the way it's receiving power. I'm just basically each of those coils where we would normally see half, well, it's AC, so we can't play this game, but it would see a half voltage drop across it. Now I'm just paralleling them so that they see the same voltage. I think it'll work. I'm not entirely sure, but it's cheap enough to try because this motor is useless to me right now, and the worst thing that's going to happen is I blow up a VFD, and VFDs are kind of cheap nowadays, so it's not horrible. And then it just lands me in the same boat of, if it doesn't work, I still have to buy a motor and a VFD, so whatever. So I'm going to keep progressing down this path, but I'll kind of show you what I'm talking about. All right, let's try to make this as simple as possible. Here is what we have. So this is how I believe the motor is currently wound. This is a star winding, and you can see there are series coils on each phase. And I have a point between each of the coils that I can measure. I believe each coil is about 3 ohms, and no matter which way I measure it, this seems to check out. Like if I go from phase 2 to phase 1, it's going through 1, 2, 3, 4 coils, so I can measure the resistance that way, or going from the common point to the middle of one. Anyways, everything checks out, so I believe this is how it's wired, which means I can switch it to this one. I mean, I can switch it to delta winding too, but I can also switch it to this winding, which I'm actually having some difficulty trying to figure out if this even exists. There's no reason this shouldn't work. This is a parallel amount of coils. I'm not changing the coil position, and I'm not changing the way it's seeing the voltage, so this should technically work and get me half the voltage. Whether or not that actually works in practice, I'm not entirely sure, but I'm gonna go down that road. So yeah, that's what I was trying to explain over there, just easier on diagrams. So testing is complete on this cap. I basically just run it to the point where I'm no longer super happy with the fit or feeling or sound or whatever. So this is what we have. Still actually really pleasing to cycle. It just comes off a little easier than I would like. This is after 10,000 cycles, machine-driven cycles, so that's going to be a little bit different than a human cycle. I mean, I tried to like introduce some randomness and change the angle of the cap going on, just try to wear out different fingers, like so it's not perfect every time. You're also going to cap it probably a lot slower than the machine is capping it, and it's hard to simulate real life with machines. But I mean, I just got to do the best I can with it. 10,000 cycles sounds like a lot. It's not much at all, honestly. I would like, ideally, if I could just make metal work to the way I want it to, I would want about 2 million cycles. To me, that would be about a lifetime, even if you're an incessant pen clicker. But I mean, switch manufacturers have difficulty hitting 2 million cycles on their switches. So that might be out of the cards, because my R&D facility probably isn't as big as some like Lutron or giant switch manufacturers. Besides the point. To not stall this design, I'm gonna make some threaded ends as well, because I know the threaded ends work super well. And then I might just include some click versions for certain customers or whatnot to be like, hey, you're buying the threaded end. I'm going to include, at no charge, a click version, and just run it and let me know how it works out. Some people, it literally might be a lifetime pen for them because they're not savages and they don't just click it on and off a bajillion times. Other people are super fidgeters, and it's going to wear out faster than I want it to. So I mean, that's the straight truth. That's the hardest thing about product design, is not actually designing things. It's designing things to work for a long period of time. Too much stuff we buy nowadays is just crap. So trying to make something that is literally like a lifetime product, quite difficult. Anyway, there's a reason I'm not making this out of titanium. I actually have a few made out of titanium. I can thin the fingers out significantly, but titanium on titanium will gall. And it also has like if you cap this thing crookedly in brass, it'll never mar the finish on the tip. It's just not hard enough to do it. The titanium ones do. They'll start scratching the tip. And I just don't like it. It doesn't look good. So like I said, I have a bunch of different ideas. They're just really difficult to machine, but I'm still gonna try it. But like I said, to not stall the design, we'll do some threaded ones. We can move forward with that, and I'll keep iterating. This is basically my workflow of how I do the box graphic design, my shipping foam design and everything. So I already have the pen box drawn up in Inkscape. I just want to change the picture of the pen on it because it isn't correct for this snap cap pen. So I go into Fusion, export the design as a DXF, and then bring it into Inkscape, and then I can plunk that exactly where I want it to be. That's all happy. I can print that, cut that out. That's easy. Next is the foam. So these are the foam carriers that go in my shipping box. I have a giant foam file that includes all the foam I use. I'm just modifying it to work with this current size pen. just putting little caps and holders and whatnot in certain areas, and holders for tools and whatnot. Then we drop that into the CO2 laser cutter, and we'll cut out all the foam pieces. I cut them in a couple stacks because we're going to glue them together later. I cut out some paper here that's just going to be used as masking. And then we go ahead and put it on my little workbench, and we're just basically going to apply some spray adhesive to the backside. I'm applying it to the wrong side. I'm actually masking the wrong piece right now, but I don't realize that yet. I'll realize that shortly. Of course, I'm doing both of them, so I ruined both of them, but that's okay. So here I realize now what I've done wrong, which is a bummer, but I basically just took a couple of the old carriers for the old Fluux pen design, peeled them apart, and then just resprayed the back of those, which will work just fine in this instance. It's kind of tedious to do like 1 or 2 of these, but if you're doing like 20, 30 of them, it actually goes pretty quickly. But I didn't want to do 20 or 30 because I'm not entirely sure if this is exactly how I'm going to build these carriers. So I don't want 30 wasted pieces of foam. I'd rather have 1 wasted piece of foam. And basically I just pick the best out of the 2 I made, and that'll go to the customer, and the other one will just be a just in case piece in case I make more mistakes. But that's my workflow of how that works, and this whole process was about 20 minutes, so it goes pretty quick. Apologies if there's fan noise in the background. It's like 9 o'clock in the morning here, and it's already 30 degrees, so I'm trying to keep it a little cooler in the shop. But this is the finished pen, basically ready for ship out. It was actually meant to leave yesterday, but yesterday was Canada Day, so the post didn't move anyways, and I figured I'd take this wonderful opportunity to show you what it looks like in its full final state. So here we have the snap action cap, and this one's actually shipping with threaded cap as well, and an extra O-ring, and it'll also come with the tool. Not this one, this is just my assembly tool. So it comes with a brand new one. So anyway, woohoo! Magnets. Basically, Fluux design, nothing crazy. The only differences on these ones, for the tip, if I unscrew this, there's a little O-ring now on the bottom of the tip section that mates into the body, and that basically just functions as a thread locking agent, if you will. It's not important on the snap caps because the snap caps snap on, there's no spinning, but on the threaded cap where you screw the cap into place over the tip, I didn't want the tip unscrewing from the pen body, and the easiest way to get around that was just to basically put an O-ring in the back end. I normally don't like using O-rings in my design if this is a problem. Magnets. Pico, are you coming to visit me? It's my cat. Normally I don't put O-rings in my designs if they're like in a function where it's like an O-ring to hold a cap on. I wouldn't normally do that because Pico, you're causing issues with the video. So curious little creatures. Anyways, normally I don't use O-rings in areas where it's sliding or whatnot because they wear out. But in this instance where the O-ring is just basically functioning as it should, it works out perfectly, so I went ahead with that. The other feature of this, since it's a dead length pen, there's no springs or anything on the inside, I wanted to make sure that, I mean, the refills are built with a pretty high degree of tolerance. So when you swap out refills, they're usually the exact same length. They're actually built to an ISO tolerance, which is pretty cool. But to accommodate any kind of issues, because I don't like issues, I put a very small, if you can see it, you know what, let's zoom. So on the back of the pen, there is a little 832 set screw, and that can be adjusted. There's just a Loctite 222 on this, so you can, I don't want to move it right now because it's already adjusted for this pen, but you could basically loosen it or tighten it to move the set screw in and out, and that would accommodate either a slightly shorter refill or a slightly longer refill. Like I said, I don't think it's going to be an issue, but nonetheless, I just like to design around issues that I think I could have in the future. So that's how that works out. And that way, when you snug the pen up, there's no woggle on the refill because that drives me crazy. So nice tight design. Very happy with that. One more time. So nice, so pleasing. So that is the pen. This has been cleaned, polished, all ready to go. Double check my magnets, because that would be embarrassing. Good. Boop. This one I'll put in like this. Tip will go in here. O-ring will go in a little bag with it. This is not the right one. Actually, smarter yet. O-ring. We'll just go. Boop. There we go. Done diddly. Pop it in the box, pop it in its other shipping box, and drop it in the mail. It's good to go. Thank you, everyone, so much for watching. That's all I have for you this week, and I will see you next week. Take care. Have fun doing it. Whatever you do. If you're a Canadian, stay cool. It's hotter than sin out there, and we'll move forward. Take care. Bye-bye. Wait, no, that's wrong. That's has to go like that. That's much better. Yes, enjoy that.